All right, folks, welcome back to today's webcast on strategic cultivation, seed to harvest. I'm your host, Ryan Douglas. We just finished a fascinating session with Agrify, speaking about automation and cultivation. And now we're going to focus on the back end of that process, which is post-harvest. So anyone that has had experience growing cannabis knows that if we don't pay close attention in the post-harvest phase, it's possible to ruin all of the previous months of hard work and expenses that went into producing that crop. So with us today, we have David Sandelman of Cannatrol. And let me grab his bio. Hey, David. David Sandelman is the co-founder of VT Dry and Cure Technologies and the inventor of Vaportrol Technology. He has been involved in the HVAC industry for over 35 years and is the inventor of 16 US patents relating to energy controls and systems. Most recently, 2 patents have been issued relating to dry cure and storage of cannabis, plus 1 additional patent pending. David is the inventor of the first 2 wired digital clock thermostat created to address the energy crisis in the 1970s and has been inventing solutions for real world problems ever since. Over the years, he has worked on cooling technologies with Oak Ridge National Laboratories and the Electric Power Research Institute. So before I hand it over to David, just to remind everyone, he'll be giving a presentation for about 45 minutes, and then at any point during the presentation, if you have questions, please enter those, and I'll read them off when he's finished presenting his slides. So, with no further ado, David, please take it away, and welcome.
Thank you. And I hope a lot of people heard David from Agrify before this talking about growing some amazing plants. And too often, we grow incredible plants and then everything goes south during the drying, curing, and storing process. And what I'd like to do here is get into a little bit of the science behind all of this. And one of the things I like to say is you can't fuck with physics, spelt with a PH. And here's an interesting quote. There's only one difference between art and science. In science, the universe is in control. In art, you are. And a great example is a hot air balloon. You can heat that balloon, it's going up. That's science. You can paint that balloon any color you want. That's art. And until now, the legacy method for drying and curing has been place the plant in an area where it's dry and let the moisture leave the plant. It could be a room with air conditioners, dehumidifiers, hanging in a barn, in a basement, in a closet. There's been all kinds of ways that people have been getting the moisture out of the plant. The issue is, in that space, moisture is constantly being removed from the flower, and unless you remove the flower from the space, it's going to be over dried. So then you put it into a sealed container where you do the curing phase, and that takes labor, moving it over. And there's a lot of guesswork in, is it dry enough? Is it too dry? Have my small buds over dried, big ones? And then once you get it into your curing space, that's where burping begins, because if you guessed and pulled it too soon and there's too much moisture in the flower, it's going to go moldy because it's sitting in that wet environment and you need to let the moisture out. But you have other variables when you open the container to burp it, and what is the outside conditions? You know, are you burping that in July in Florida, or are you burping that container in January in northern Vermont? The conditions of the air are completely different. And then you put that in storage, and unless the conditions at storage are right, the product is going to continue to degrade. So let's talk about what we're actually trying to do. What we really want to do is remove the free available from the flower to a 0.6, 0.65 water activity. Water activity is something the food industry has used for decades. That's when they know they can put the crackers in the package and they're not going to go rancid. Even museums use water activity for fine old books to measure that there's not enough water in there. for molds and other things to grow. So once you get down to that 0.6, 0.65 water activity, there isn't enough what's called free available water for these nasties to feed on and grow. What you wind up with then is bound water that's not available to them. So our goal in drying and curing is get the free available water out and then hold it there. And now you're going to cure and store the product in the flower in ideal conditions, and you're going to wind up with some amazing flower, high terpenes, texture, feel. People just keep coming back for it. And wait. So one of the myths we hear a lot is, the key is to control the humidity. Well, you really can't control humidity because it's relative. And with the Cannatrol systems and our technology, you're controlling the vapor pressure. And vapor pressure is what's key to the water leaving the flower and coming to a stable, shelf-stable product with the right target water activity. And I'll get into a little bit of it's all relative. People say, I want my relative humidity at 60%. And if you look at this chart here, you will see there are so many solutions for 60% relative humidity. If you change the dew point, you change the relative humidity. If you change the temperature in the space, you change the relative humidity. And that's why people are constantly chasing relative humidity, because you cannot control relative humidity because it's made of two variables. You need to control the variables that make up that relative humidity, which is what our Vaportrol technology is all about. Let's do a quick thought experiment here. Imagine you have a cube, it's acrylic, and it's sealed. And what we're going to do is put a drop of water inside of that cube and seal it again. So we have a little drop, and now it's going to evaporate, so that water droplet has turned to gas. So now what we have in there is water vapor at a particular vapor pressure. And the result is an RH of 50% inside that cube. Now, if we take and warm that box up, we'll put a candle on it and heat the air inside the box. What's going to happen is, when we started with the 50% relative humidity inside the box, it's going to drop to 20%. But the amount of water and the vapor pressure in that box hasn't changed. Because what relative humidity is doing is expressing air's ability to hold water. So by heating the air in that box, that air can now hold more water. We haven't changed the amount of water in the box, but we've given that warm air the capacity to hold more water. But the key is the vapor pressure hasn't changed in there. Another way to look at it is, imagine these two balloons here, and both of them are filled to 90%. But the balloon on the left would be in an example of warmer air. It can hold more water, where the balloon on the right is a cooler air temperature, so it holds less water. But the absolute amount of water is completely different, but yet the relative humidity is the same. And this is where room temperature in a space has a significant effect on what's going on with relative humidity. And when watching relative humidity, what's happening with the absolute amount of water vapor in the air, which doesn't change, but the RH does. We're going to flip this around, and now we're going to put 6 ounces of water in the two balloons, but the balloon on the left, being warmer, only shows it's 20% full because it can hold a lot more water. But again, we still have the same amount of water in the right-hand balloon, which is colder, and colder air holds less water, so the relative humidity would be higher. So the point we're trying to make here is relative humidity isn't a very relative number when taken just as a number on its own. So when we're talking about Vaportrol technology, we're talking about vapor pressure and dew point. Those are the key values you want to talk about. And what we do know is, if we know the vapor pressure, we can calculate dew point. And if we know the dew point, we can calculate the vapor pressure. We have the equation here, and people who are smarter than I am can probably flip it around, but you can see you can solve for one or the other. They're interchangeable. Now, an interesting thing about pressure and Boyle's law is pressure equalizes through a space. So when you have good vapor pressure control, you're going to have even vapor pressure throughout the space, which is going to give you even drying throughout the space. And a good example here is you have a tire, and it doesn't matter whether you're going to be measuring the tire pressure with the valve stem on the top or the valve stem on the bottom. The pressure throughout is equal, and the same thing will happen in a room with vapor pressure. That's Boyle's law that brings the science into play. Now, I'm sure a lot of you have heard vapor pressure deficit, which is a measurement used to measure the vapor pressure at saturation under a leaf and the room. But it also applies to the difference in vapor pressure when drying flower. And here's a perfect example of an extreme of vapor pressure deficit. When you puncture the tire, the high vapor pressure in the tire is going to equalize with the low vapor pressure outside and come to equilibrium. And again, here, it doesn't matter whether you're measuring the tire pressure at the bottom or the top, it's all the same. It's going to be equal. So how does this relate to a flower? So when we have a fresh cut flower, that fresh cut flower has a high vapor pressure. And have some numbers here. The fresh cut flower is going to have a vapor pressure of approximately 23.39 millibars, and you can convert that to PSI. This is not air pressure, this is vapor pressure. And a properly controlled drying room will have a vapor pressure of 14.24 millibars. So what's going to happen? The free available water, which is represented by the little free blue raindrops here, are going to leave the flower and be absorbed into the room because the vapor pressure wants to equalize throughout. And what we want to retain are the little droplets in the red circles. Those are bound water. That bound water will not promote mold growth. The microbes can't get to that water because it's bound up. So what we need to do is get rid of the free available water. And once we do, we've got a shelf-stable product. And we're going to take this to show you what happens in an actual space. If we're holding a room, and we found with lots and lots of facilities drying and curing, a 68-degree dry bulb and a 54-degree dew point gives you some amazing dried flower. The relative humidity calculates to 61%. Again, we're not controlling relative humidity. Relative humidity is the result of control of the dry bulb and dew point. And here we have a pressure of 14.24 millibars, which is going to be where we want that flower to equalize and come to equilibrium. But here's some of the challenges everyone faces with their drying and curing rooms, all different types, with air conditioners, dehumidifiers. You want to maintain the space with a dry bulb of 68 degrees and a 54-degree dew point. The issue is, if it's a winter day outside, you're going to have a vapor pressure of 2.86 millibars. The outside vapor pressure is 3 times lower than what's in the room, or the room is 3 times greater. And again, what's going to happen is that room is going to want to equalize with what's going on outside. And your building comes to equilibrium with outside because the vapor pressure will equalize through fresh air ducts, makeup air, open doors. The building stays and will have a very low vapor pressure in the lower months, even though it feels comfortable. If you actually measure the dew point, you'll see it's very low. And that becomes a problem when you're trying to dry in a space and have some control. You wind up with the flower drying too quickly, and you're out of control because the mechanical equipment you're using is really working against what's going on with the outdoor conditions, not so much the flower. And the reverse happens. Imagine in a hot, wet climate, something like a Florida day. It's not even too extreme in this example, with an 85-degree dry bulb, a 77-degree dew point. Your vapor pressure is 31.61. Yet we have a target that's much lower than that. What we're looking for in that room is about 3.8 times less than what it is outside. So whatever mechanical equipment you have going on to try and maintain the right vapor pressure in the room for drying, you're trying to empty the ocean with a bucket. As quickly as that mechanical equipment is pulling water out of the air, and your objective is to get the water out of the flower, it's really just keeps taking water out of the air that keeps getting sucked in from the outside conditions. So you wind up with this constant battle year round. In the winter months, it's too dry outside and it's robbing the moisture from your dry cure space. In the summer months, it's too wet outside. And part of it has to do with the construction of the rooms. Dry and curing spaces need to be vapor-tight spaces built with monolithic panels, products like Duramax, Truss Core, where all the seams and cracks are siliconed or caulked, so you have a vapor-tight space. You always want to think about the construction of, let's say, a walk-in cooler. And why is a walk-in cooler vapor-tight, or your refrigerator at home vapor-tight? It's so that it's maintaining a low vapor pressure in that space. And you don't want to be constantly drawing in high vapor pressure air from outside the refrigerator, the walk-in cooler, because then the system is constantly removing water from the outside. Or the reverse, in the winter, you don't want your produce or products in your refrigerator to over dry and dry out because you're constantly losing moisture to the outside. So that's why these rooms are sealed. They have gaskets. You certainly don't want to construct a dry cure space with drop-in ceiling tiles or have it open to a open truss steel deck system. That just is impossible to get any decent control there. Now, how we've always been doing it is with a lot of use of mini splits, dehumidifiers, rooftop air conditioners. And what we're trying to do is pull the moisture out of the flower. But these systems continually remove moisture. And that's the reason why it's a drying room, not a drying curing space, which is what we do. It's a drying room because unless you pull the flower, every time that air conditioner cycles on, a 410 refrigerant will start creating a vapor pressure of 5.41 versus your target of 14.24. So every time the compressor cycles on, you're going to have this huge vapor pressure deficit, and you're going to just keep pulling more and more water out of the flower. Even though you might be seeing a humidity at the right point, you're chasing it because the compressors keep pulling out extra water. And that's why the flower then needs to be moved out of traditional dry space and put into a bag, a vessel, a jar, where then the burping begins. Well, some of you are going to say, hey, I get good results sometimes. Well, you know, even a broken clock is right twice a day. And that's what happens with a lot of dry cure facilities. It turns out there's a couple of days in the spring and a couple of days in the fall when the weather conditions are just right, where your temperature outside, your dew point outside are in the right conditions. That might last a couple of days. It might last a couple of hours. Here in Vermont during the fall, we might have perfect dry bulb and dew point conditions midday, and then the dew point at night drops like a rock, and that will cause a flower to over dry. Or we might get a stretch of rainy days and the dew point is really high. And then that becomes a challenge, because if you don't get that free available water out of the flower quickly, you're going to wind up with the right conditions for mold and other things to take hold. What I'd like to do here, though, is because we've been talking about free available water, you know, the free available water is a function of water activity. And we're shooting for that water activity of 0.6, 0.65. And that has to do with the vapor pressure of the flower and where it is as far as water at saturation. Now, there is a difference between water activity and moisture content. Water activity is measuring the free available water and unbound water and bound water. And that's our target. We want to get to that target water activity where it won't support mold and other growth. On the other side, people are using moisture meters and measuring the total moisture. And how a moisture meter works is it's going to weigh the flower. You're then going to heat the flower to the point where all water is boiled off, it is completely dehydrated dry, and weigh it again. And now you have a percent of how much water was there. The difference is when you're measuring moisture content, you might be removing more water than is necessary to get to a shelf-stable product. And loss of water is loss of weight, is loss of revenue. We're hearing people have anywhere from 2 to 7% increase in yield because they are not over-drying the products. And an over-dried product tends to be an inferior product to a properly dried and then cured product. So what normally happens is if you leave the flower in a space that's actively drying all the time, you're just going to keep pulling water out and you're going to drop below your target water activity, and you're going to wind up with a product that's over-dried and you've lost weight, which is revenue. On the other side, if you pull the flower out of the dry space too soon, it's going to have free available water in it. And if it's placed in a space for curing in a bag or a jar, that's when things can start growing in there because there is that free available water available to it. And this is where the burping process becomes key and critical. And what are the conditions in the room when you open up those turkey bags or jars? So the ideal solution is when you're using Vaportrol technology, you're putting the flower in a space that's at your target level for water activity. So what happens? The flower goes in, it's got free available water, it will lose that free available water and come to equilibrium with the vapor pressure in the space. At that point, no additional water is leaving the product, and you are now curing. You don't have to touch the product. You don't have to move the product. You can get a couple of days cure and you can go right to packaging from there. Or you can leave the product in that space. We've had product held at the right vapor pressure for as long as 2 years, and people are absolutely blown away by the quality of the product that's 2 years old. So this eliminates labor and time. We had one large facility. They said we saved them 10 days from the time of harvest to the time of the product going out the door, because they no longer were having to take the flower out of their drying space, put it into vessels, turkey bags, who knows what, different types of containers, and then having someone monitor it for burping and then eventually going. We cut 10 days of labor off that process. Also, what happens is when you're putting the flower in a space that's just dry and continually removing moisture, you're going to find the small buds are going to lose the moisture faster than the large ones. Well, no one's going to go in there and pull all the small buds first and then leave the larger colas and flowers to dry a little further so they're all at the same target. So what you wind up with is some compromise. With the Vaportrol technology, with the flower in the room at the right vapor pressure, the small flowers will dry a little faster than the larger ones, but after another couple of hours or a day, they all come to equilibrium and they're all dried to the same place. You know, another way of looking at this is, I don't know how many people there have ever cooked with sous vide, where you can put a piece of meat in a sous vide and after 2 hours it's done, but you can leave it in there for 12 hours. It's not going to overcook. It's going to be perfect whether you pull it at 2 hours, 6 hours, 12 hours. But if you were to cook that piece of meat in an oven, well, you have to pull it out exactly at the precise time. If you pull it out too soon, it's undercooked, or if you leave it in the oven too long, it's going to be overcooked. And the same thing applies to a large piece and a small piece. The small piece is going to cook faster than the large piece. And the same thing happens with a flower that you're drying with the Vaportrol technology, where you're controlling the vapor pressure. Once that flower reaches equilibrium with the space and it's at the target water activity, you can leave it in there for days or months. We've had other facilities where they have to have people on call and they're watching and looking, when is it time to pull the flower from the dry room? And then they're concerned, is it going to happen on Saturday or Sunday, and they don't have a crew until Monday? It's going to be over dried. With Vaportrol technology, leave the flower in there. It's going to start curing. It gets better with time. And we see some amazing results with how now, when you have good control over the conditions the flower is maintained in, curing. Before, it was a guess game. It was in a bottle or in a jar. Here, you're maintaining the exact perfect conditions for the flower, and really can start comparing flower that's been cured for a week or a month. And we're seeing differences between different cultivars because it's an agricultural product. A couple of things that come about when properly drying, curing, and storing as a complete and continuous controlled product is increased yield by weight, reduced labor, increased potency, increased terpenes. The product is consistent, repeatable, and the customers keep coming back for more. What we're hearing is facilities that are using this technology for their drying and curing, and if they have multiple rooms and they say, let's try one room, they quickly find out their consumers and customers no longer want the product that they were drying and then moving to a curing space conventionally, where their consumers were demanding that they only get the product that was coming out of the Cannatrol dry cure systems. So let's take some questions. And
Hey, David, that was great stuff. Much appreciated. Yep, so as David said, please, any questions related to this drying technology, please do send those along. We've got a question right off the bat from Gregory. He's asking, help me better understand what the similarities and differences are between Cannatrol, Cannafreeze, and CryoCure systems.
Okay, so those systems are freeze drying. So what they're doing is lowering the vapor pressure and cooling the product and pulling all the moisture out of it. What we're doing is we're gently drying the product. You know, I sometimes like to think about freeze drying like a Sanka coffee compared to a fresh roasted brewed coffee. That would be a good comparison. We're holding moisture and yield in the product. If you weigh side by side, our finished flower will come out with a higher weight. And at the end of the day, we're selling product by weight.
Of course. Excellent. And so, I mean, a lot of what you say here appeals to me as a grower that has run a commercial facility and had to train people to identify the correct time to stop the drying process. And as someone that has been in dry rooms and opened and closed and burped more buckets than I care to think of, this is really a beautiful thing, because when a product stops curing, if we're using the traditional burping method, it's so subjective, right? In my opinion, it could be something different. How do I train someone to look for that? And then, you know, a grower or someone in the post-harvest department might have a slightly different opinion, slightly different experience. And it's almost impossible when you think about it to have a consistent program, because we're training on something that's so subjective and subject to opinion.
That's
so
correct.
This really takes that element out of things.
It eliminates all of that. You just have repeatable, consistent results, batch after batch after batch, and you're not fighting the climate. You know, where what you were just talking about, you train one person in the summer and everything is different in the winter. That's all eliminated. With our system, whether it's January or August, you're going to get the same product every time.
Excellent. And we've got a number of great questions here. Just before I forget, this technology, can you talk about the different sizes? Is this for commercial growers? Is it for home growers? What kind of volume are we talking about?
We make across the full spectrum. We make a home unit that takes 2 pounds of wet flour for the consumer, and we sell thousands of those worldwide. And then we do large systems. We have a kit system. We call that DC4. It takes between 160 and 180 pounds of wet flour. It comes as a knockdown kit. It could be stood up in a day. You have it running by day 2. You're starting to run flour through it. And then we have an 8, which takes 320 pounds, and then a 16, which takes 320, 640, 640 pounds of flour.
Wet
Wet
flour?
flour going in. Yep. And you'll have sellable product in about 8 days. Now, some people like to leave it in a little bit longer, 10 days, because now they're starting to experience the difference in the quality of the product, because now you're getting some cure. So they say, you know what? Let's leave it in there a couple of more days. Then after that, we're doing a lot of retrofits. We have a lot of facilities that have dehumidifiers and mini splits and air conditioners in their rooms. And as our equipment is being installed in certain areas of the country, the competition is quickly finding out how they're doing it, because the consumer keeps coming back looking for product that's dried and cured with the Cannatrol technology, and they no longer want product that's conventionally dried, then cured with the burping.
And I've seen the 2-pound model in person. Just roughly, how big is that? The one that does 640 pounds wet? Is it like a tractor
Oh,
trailer size?
640 pound, that room is about 9 feet across, 9 feet high, and I'm going to say about 14 to 15 feet deep. And it
Wow.
comes as panels knocked down. We just had one leave the dock yesterday, and it left on 2 4x10 pallets. He was driving home to Michigan with it, and he'll have it set up in no time. We did 6 of those at a facility in Massachusetts where they had the big room, they had the dehumidifier, the air conditioners, nets and nets and nets. And they tried one of our 160-pound units, and I don't know, 2-3 months later, they ordered 6 of the 320-pound units, and they came on 2 tractor trailers, and I was say about 10 days later, they were lighting them up and running them already. And they built them in their existing dry rooms with all the netting. They just moved the netting over, and so they were able to keep going with minimal interruption to their space. So we're seeing all kinds of retrofits and build outs. We've done build outs where they did 4 1,000-pound rooms built during construction, but we also did a trim room and a long-term storage room. So the flour, as it was harvested, came directly into the trim room, which was already at the right temperature and vapor pressure. So the plant never was subject to the random air conditioning in corridors or what and left there. No, it went right into trim. They trimmed it down, put it on carts, then ran it down a corridor into one of the 4 dry rooms. So all of the space is properly controlled. Then when they pull it from the dry room, goes back to trim for final trim and packing. And then they would set aside certain amounts, whether supply was greater than demands, or they wanted to segregate to do a premium cure and move it down the hall into the storeroom. Because now you start thinking about premium wines, premium bourbons. What are they doing? They're aging them, and they're improving with time and getting a premium dollar for it.
Of course. Cool stuff. All right, we've got a handful of questions here from our listeners. Matt is asking, once a flower is at the ideal moisture content, what does burping do? Is it worth the labor?
Great question. So if it's in one of our systems, there is no burping. The flower just sits in there. It is held at the perfect conditions. Now, when you start talking about burping, if you have the flower, let's say in a mason jar, and it's at the perfect conditions, the last thing you want to do is open that jar. Because if you open the jar and the climate is wet and it is higher dew point and vapor pressure than you want, you're going to put wet water, wet air into that, which you don't want to do. Or if it's the winter and very dry and you open the jar, you're going to let bone dry air into the jar. You're going to close the lid, and now the flower is going to want to equalize the water content in the jar and rehydrate the jar, and you're going to lose water vapor and start over drying that flower. So you really need to open the jar when you're at the right dew point and temperature. And if you're in a Cannatrol system with vapor pressure control, there's no point in putting it in a closed jar. And that's how we recommend people leave their flower in the rooms open, or in the small home units, we recommend people put the flower in brown paper sandwich bags. Why? Because the brown paper sandwich bag is vapor permeable, and this way they can keep their different cultivars separate. You write on the bag with a Sharpie what day it was harvested, what variety it is, and then you have a whole library. You open the door, it's like, oh, what would you like to choose today? But they're all maintained at the perfect condition.
And talk to me about that product that you had in there for 2 years.
It was Acapulco. Was it Acapulco Gold? I don't remember. Well, what happened is it did brown a little bit due to oxidation. Okay, but when you took the flower out, it was still supple. It didn't just go poof and turn to dust. And anyone we showed it to said, no way, that is not 2-year-old flower. It smoked well, it had great flavor and great taste. The biggest downside was the oxidation, and it did definitely brown.
Yeah, well, I mean, you get that even with cannabis you've had in a glass jar in your cupboard for a year or two. But wow, 2 years, that's fascinating stuff.
Another story we had was we grew a Jilly Bean and an Acapulco Gold side by side. After 8 days in a Cannatrol with the right vapor pressure, that Jilly Bean was excellent as always. The Acapulco Gold, we were a bit of weed snobs, said throw it away, it's disgusting. No, we left it in for another 30 days. And after 30 days of curing, it became the new favorite. Think about that bottle of wine that's young and wild and this isn't very good. And you put it down for a while in the cellar, you break it out, wow, it's amazing. Same thing happens with a cannabis flower when properly cured.
All right. Adam is asking, do different strains have different amounts of bound water? And how do you determine the strain's capacity to hold bound water?
Okay, so that gets down to basic physics. That has nothing to do with the strain, because you're going to measure water activity of a rare book in a museum. You're going to measure water activity, a piece of charcuterie. You're going to measure water activity on crackers. And the science is when you're at 0.6, 0.65, no matter what it is, a piece of paper, a piece of meat, you now have a shelf-stable product where there's enough water bound up that microbes can't eat on it. And that's why that piece of charcuterie is shelf stable, because of the bound water is bound up and rot can't get in there. So the cultivar and the variety doesn't matter. It's a physics problem that's universal to all things that mold will grow on.
You know, I didn't follow much physics in high school, but if we were talking about marijuana as an example, I think it would have sunk in much better than it did. Okay, next question. Ryan is asking, can flowers be removed from stems before using this technology, or is it better to hang the plants whole or cut branch by branch?
All right, this is a great, great question. And we've tried it. So what we've done is we took the flowers off the stems. We've left medium length stems and long stems. We've done drying on trays. We've done drying hanging. And what we find is that when it's cut down to a flower just to dry, it will dry faster than when it's on the stem. And the longer the stem, the longer it takes to dry. Now you're using time and energy to remove water that's probably in the stems, which isn't very useful in the end product. But for some people, it's more convenient to hang them on the stems. And another thing we then see is because the flower dries a little slower on the stem, using traditional methods, if you had poor control over the environment, it acted as a buffer. You couldn't go from good to bad so fast. You had, because it was drying a little slower, you had a little bit more leeway. Where if you just had a flower, you can go from good to bad quickly if you didn't have good control over the space. But with our system, a lot of our big producers just trim, put them on trays. They're interested in square footage, density, and speed and time. But boy, we do a lot of systems that people like to hang, and great, we'll do either one.
Nice. Good to hear that it's flexible. Joseph is asking, what equipment is used to maintain dew point? Can this be used at scale affordably?
Well, that's the Cannatrol Vaportrol technology that maintains the dew point. We've got 2 patents on it. We've got a third coming along the way. Our equipment typically has less than a 1-year ROI between, maintaining yield. We have facilities that are doing, several thousand pounds a month. And if you pick up 2 to 3%, 5%, we've heard as high as 7%, and that drops straight to the bottom line, you've got some pretty fast ROI. Others are said they're seeing high, the terpenes have increased, potency has increased, all of it raising the value of the flower they're producing. I think in the earliest session, David was talking about, if you can spend the money on the technology up front, it more than pays for itself on the back end.
That makes sense. Joseph has a follow-up question. I think you might have answered it previously. Does the flower need to be bucked down? It sounds like
It's
customers would have an option, right?
customer's choice. That's right.
Okay.
I'd like to bring up one point, and that is, people are asking about water activity. There's a white paper from a company called Rotronic that just talks about water activity in no particular industry, and it's fascinating. And anyone who requests it, we'll send a link to their website with that paper.
Okay, excellent. That's good to know. Outstanding. Gregory is asking, what Cannatrol system would you recommend for a craft grower initially growing about 500 pounds a year? And what would a system like that cost?
Okay, so when we size our systems, a lot of people start with how many square feet their drying room is. And what we talk about is how many wet pounds, because we're going back to physics. And the system is sized for how many pounds of water do we need to remove from that flower. And that translates to energy and BTUs, and that's how we size the system. The next component for sizing the system is how often do you harvest? Are you harvesting once a month, once a year? Because we like to size a room to be able to take a day's worth of production. And the reason is we don't like to see when you fill a room and you now already start drying the flower on day 2 or 3 to bring wet flower in on top of that already dry flower or flower that's well on its way to drying. I like to use the example, you wouldn't throw wet towels on top of towels in your clothes dryer that are almost dry. You'll never get anywhere. So we like to size the systems based on labor, manpower that you can harvest in a day, and we size it based on wet pounds. If someone just knows what their dry pounds are, we typically multiply it times 5, knowing that you're going to have about a 20% yield of dry weight as compared to wet weight. So I didn't answer his question with an answer, but I raised it with a couple of questions. How often is he going to harvest? How large is his harvest cycle when he does load a room? And then we can size a room. To put things in perspective, our 180-pound room, that's 180 wet pounds coming in, starts at $42,000. That's a complete turnkey kit.
Excellent. And that was how the volume on that was how much?
160 to 180 wet pounds going in. So 20% of that, you'll yield about 36, 40 pounds of finished dry flower. So you can then figure out what your market will pay for that amount of flower and quickly do some quick ROI on what is a $40,000 to $50,000 capital cost that then is going to run for many, many years.
And the difference is, without this technology, if you're selling product that's drier, you're missing out on that potential revenue. It literally evaporates, right?
That's correct. It's just evaporating. But what, originally we're looking at the straight ROI on weight, but we're hearing more and more from people using the equipment. It's the customers keep coming back for more.
And so are you primarily in the US?
Yes, our small systems are, we've shipped worldwide. Our large systems, we're now talking to a couple of European facilities, large grow facilities that supplies several countries. So we're in that process right now.
Excellent. Okay, so hopefully, Greg, that answered your question. Next one, how long will it take to dry and cure a pound of flour? I have heard Canna-Freeze dries in 24 hours. What are the advantages of the Cannatrol system? Savannah.
Well, in our opinion, a far better product. There was a lawnmower ad. It's not how fast you cut, it's how well you cut fast. So we get to a target water activity typically in about 4 days, and we like to see another 4 days of cure. So in 8 days, you have amazing smokable product without any burping, jars, moving, nothing. You just leave it there. 8 days later, you're done. So the initial, how fast you do it, then what are you going to do after as far as curing? What's the difference in the yield as far as weight? What's the difference in the quality?
So smokable flour after 8 days.
Yes.
Nice. And up to 2 years or longer.
Yes. Yep.
Excellent. Okay. Second question, how are you measuring AW in the flour? Building sensors, removing samples?
Yes. We use a water activity meter, and we'll pull a sample. You put it in the water activity meter. You can get a quick read on a good water activity meter in about 5 minutes. And a decent water activity meter starts at about $3,000. And that's part of the reason that there's still a lot of moisture content read, because people were using moisture readers that you use for 2x4s and lumber. They're cheap. Just a basic moisture meter that uses a scale and a heater are far less expensive than a water activity meter. But boy, it's a worthwhile investment for anyone who is drying flour. That's when you know it's done. That's the science.
Excellent. Okay, Ernest is asking for the $42,000 unit from harvest until sale time, how long in the unit? I think you might have just answered that.
8 days.
8 days, okay, excellent. All right, I think we ran through all of our listener questions. Please, if there's any additional questions, we still have some time left, so please don't hesitate. I don't know, this is kind of a general question, but I think it warrants driving down on the point. I mean, why is correctly drying or curing or storing cannabis so important, in your opinion?
Oh, it's the finished product. You know, people grow amazing plants and then absolutely destroy them during the dry cure. You know, you can select all different types of lights, all different types of nutrients, but the consumer at the end, they're most affected by what happens during the dry and cure storage. They couldn't tell the difference between 2 different lights or 2 different nutrients, but you supply the consumer with a well-dried and cured product and a poorly dry cured product, they know it immediately. We've done a panel test and blind test, and people 2 to 1 would select the flour that came out of a Cannatrol system over a conventional dry cure system. And that's, you know, it's important now. There's been in the industry a race to the bottom. How fast can I grow this? How fast can I dry it? How cheap can I make it? And commoditized it. And what we're doing is providing the technology for growers to start doing craft and differentiate themselves. You know, the craft beers compared to Budweiser. There's a market out there. High-end wines. You know, I like to use the example, $5 bottle of wine, a $50 bottle of wine. Both chug them down, they're both going to get you just as drunk and just as sick. So why does the consumer waste money and pay $50 for a bottle of wine? It's the experience of the finished product.
And I mentioned at the very start of today's presentations that I don't think competing with mediocre cannabis is really a recipe for success, especially for groups that are looking to get into the business or expanding their existing cultivation businesses. I think you're totally right. The focus has to be on the quality, because if the goal is high volume, low cost, and just crank it out there, How are
No
you
one,
going to differentiate yourself? How long is
nope,
that business model going to survive?
correct. So that's where we're seeing a lot of interest in our product, is people who are done racing to the bottom and say, I'm taking a time out. I want to take my product up. I want to have a brand that people recognize and people ask for and come back for. I had one facility, not going to name where or when, but I went in there after a startup, and every marking of our name on the product, it was with one of these big walk-in rooms, was removed. And I said, what happened to all our name tags and stickers and labels on here? He says, I don't want anyone to know what my secret weapon is.
Yep, you find that kind of thing now and again. Well, that's a compliment. That's great. You know, I think another advantage of this system is that it eliminates the learning curve for how to dry cannabis, especially on a commercial scale. So like
Correct.
we both mentioned that you can have the most amazing genetics and state-of-the-art facility and the world-class grower. But the second that product is harvested, how it's treated, under what conditions it's stored or processed makes all the difference. And I've learned firsthand where I've grown or have worked with a cultivation team that's growing varieties that smell amazing all the way through production. And you know, like most cannabis varieties, when they begin flowering, the terpene expression is a little bit different than when they're finally mature. But you know, if you have an outstanding variety, it's a beautiful thing to smell all the way through the end, and you're so excited for that final product to be dried and cured so you can consume it. But what I've found in my experience, unfortunately, is if those set points or the process or the handling of that product isn't correct, everything starts to smell the same, right? We've destroyed the most valuable aspects, characteristics of that product. And as a grower, you know, you're in there 6-7 days a week. The company has invested a ton of money in personnel and equipment, and they likely have customers or investors that are waiting for this harvest to finish and be sold. And it's unbelievable that in the course of literally a week, sometimes even a couple days, you can absolutely destroy all of that work and investment that happened beforehand. So talking from experience in trying to train people in the post-harvest department, how to maintain the perfect conditions and what to do at what stage, this system really eliminates that learning curve.
Completely.
And if you think the average flower room, what's the value of one crop in one flower room? Typically it exceeds 6 figures.
That's right.
And so if you don't have a technology like this, if we're just drying and curing traditionally, there's a very good chance that we could do it incorrectly before the team kind of gets in their groove. And when we talk about what's the cost of that learning curve, right? It can be several times $100,000, right?
Oh
I
yeah.
mean, that's not unheard of.
Now we're seeing MSOs, they put us in one facility, and once they're running it, they're like, we got to move this to our, do this in our other facilities, because it's a no-brainer as far as training staff turnover. You just, with our small box with homeowners, we say, set it and forget it. Just close the door, push start, come back in 8 days.
Nice. It's ideal for startups and for expansion projects. It
Yep.
eliminates any risk in the training area.
You bring up an
Okay, so
interesting point about terpenes, and we get people that say, when the flower comes out of our systems, they don't have as much robust smell as they used to. And it's because we retain the terpenes, we're sealing them in. And we're going to be studying the kinetics of what's going on in the flower. So we tell people is take that flower, break it open and smell it. And usually all you hear is, oh my, I've never smelt anything like that.
all right. So the last 5 minutes here, we've got a couple more questions. Greg says, it seems like technology in the field of drying and curing is advancing at exponential rates. You said that these units last years. What happens when you invest significantly into one of these systems and the technology changes in a year or two?
Well, we're talking about physics. And so we're now applying physics to the cannabis flower. Unless physics starts to change, I don't see this becoming obsolete anytime soon.
Great answer. Joseph is asking if the air handlers in the Cannatrol system is different than those used in the food industry.
So Our technology came out of the food industry. We started 15 years ago doing cheese aging rooms, where people wanted to make any kind of cheese anywhere in the world, any time of the year. And so we were able to create the conditions in a cave wherever they were. And that's what the technology was originally developed when a cheesemaker said, I can't control the humidity in my cheese aging room. And I said, that's right, you can't control humidity. So we came up with the first concept of it, did some prototyping, and it worked. And now we have hundreds of artisan cheese facilities all over that use this technology. A couple of months ago was the American Cheese Society competition. I think there were close to 3,000 entries, and the top 4 ribbon takers had our technology in their cheese aging rooms. We also use this in charcuterie rooms to make various cured salamis and things. The meat industry uses it for dry aged beef, dry aged steak. And it was from that we said, wow, I wonder if this would work on a cannabis flower. And here we are today.
Well, I'm getting hungry just listening to all the different applications for this technology. All the way from cheese.
Samples are great when we do visits to various facilities.
From cheese to cannabis. All right. Okay, so maybe this can be our last question. Greg has a follow-up question. He asked about advances in technology. He's asking if you provide any trade-in opportunities if or when the technology advances and we would want a newer, more innovative system from you.
Well, it's something we'd have to see when we get there, if there are advances, but we're doing some pretty basic physics. So as long as that holds, we're not using any gimmicks, and there are a lot of gimmicks out there. And so we're just working on some basic physics and science. So I'm going to say this is going to be around for a real long time.
And remind me, how long have you been at it, from the experiments with the cheese all the way up to today?
Oh, over 15 years.
All right. Excellent. All right, folks, that brings us right to the end of our time. I want to thank David for participating, for his presentation and answering everyone's questions.
Thank you.
We're going to take a brief break here for 15 minutes, and then I'll be back with the final presentation of today, talking about some best practices for the commercial cultivation of cannabis.
Excellent.
So thanks again, David. Thanks to all our listeners, and we'll see you back here in about 15 minutes.